Good day, everyone. Welcome back to our physics class. Today, we'll be looking at the continuation of speed, velocity, and acceleration. Before I proceed, our lesson objective. At the end of the lesson, learners will be able to define velocity, define acceleration, and solve questions relating to uniform acceleration of motion. Now, velocity. Velocity can be defined as the rate of change of displacement with respect to time. Mathematically, velocity is equal to displacement over time, which is d over t. And acceleration can be defined as the increasing rate of change of velocity with respect to time. That is, acceleration is equal to rate of change in velocity over time. These two terms leads us to the equation of uniform acceleration of motion. And uniform acceleration of motion. This velocity and acceleration is one that leads us to the equation of uniform acceleration of motion. Now, let me state the equation of uniform acceleration of motion. Number one, v is equal to u plus at. This is the first equation. And the second equation too is v squared is equal to u squared plus 2as. The equation 2. 3. Equation 3 says s is equal to ut plus half at squared. Equation 3. And the fourth one is s is equal to u plus v over 2. Close bracket and open bracket t. This is the equation 4. All these terms, v is the final velocity and u is our initial velocity, while the a is the acceleration and the t is the time. This u plus v over 2 is the what? The average velocity of the what? Of the object in uniform acceleration. Now, let's consider this question. A particle accelerates uniformly from rest at 6.0 meters per second square for 8 seconds and then decelerate uniformly to rest in the next 5 seconds. Determine the magnitude of the deceleration. Now, this question, before you start solving, write out the given data in the question first. Now, solution. Given data. The first data given is what? They said a particle accelerates uniformly from rest at 6.0 meters per second. Now, the acceleration is given. A is equal to 6.0 meters per second. Now, note, when a particle starts from rest, the initial velocity is 0. And when a particle comes to rest, the final velocity is 0. Third one, when a body's velocity is constant or not changing, acceleration there is 0. Now, let's continue. Now, here they said a particle accelerates uniformly from rest, that is the u, that is in initial velocity, which is u, is what? 0. Now, for 8 seconds, that is t is 8 seconds. And then decelerate uniformly to rest. Before we move to that, now, v is unknown here. Let's find the v first. Now, you can now what? Look at the given data first. From the equation of uniform acceleration of motion, our v is equal to u plus at. Now, v is equal to What is our U? 0. Plus, what is our A? Acceleration. 6 times, what is our T? 8 seconds. That is 6 times 8. 6 times 8 is equal to, that's 48. Our V is equal to 48 meter per second. Now, we've gotten our what? Our velocity when the body starts from rest. But here, they said, and then decelerate uniformly to rest in the next 5 seconds. Determine the magnitude of what? Deceleration. Deceleration, like I said earlier, is what? Negative acceleration. Now, when the body decelerates, so our V is 0 and the initial velocity will be 48 meter per second. The velocity that it takes to decelerate will not be our initial velocity. So the same formula, which is V is equals to U plus AT. Our V is 0 and initial velocity is what? 48 meter per second. 48 meter per second plus the acceleration we have to look for and the time it takes to decelerate, which is what? 5. Then you now make what? Make A the subject of the formula. Then when this plus 5A cross to the other side, it will now come to what? Minus 5A is equal to 48. So now, we want to make A the subject of the formula. Divide both sides by what? The coefficient of A, which is minus 5. 5 here, 5 here. 5 cancel 5. 5 here, 5 in 48. 48 divided by 5. That is 9.6. Now, our negative acceleration is 9.6. We won't put the negative in the acceleration. We all know that deceleration is negative acceleration. So our A is now equal to 9.6 meter per second square. That's our final answer. Thank you so much for your attention. Kindly please like, share, and comment under the comment section. Thank you.